Welcome, everyone, to Open Connectivity Foundation's The Future of Connected Buildings webinar. Today's webinar will feature expert insights into the connected buildings ecosystem, market trends, and more, followed by a panel discussion. If time allows, we'll take questions from the audience. If you have any questions, please submit them via the Q&A box. A recording of this webinar will be made available following the event. Our speakers today include Adarsh Krishnan, Research Director of ABI Research, Bruno Johnson, CEO of Cascoda and Vice Chair of the Marketing and Communications Work Group of OCF, and Niels Gunnar-Frins, CEO of MBS. Adarsh, I will now hand it over to you.
Alison, firstly, thanks everyone. I'd like to thank everyone for joining this webinar today. Those who are not familiar with ABI Research, we are a leading market intelligence and advisory firm. For the last 30 years, have been providing actionable insight and strategic guidance on transformative technologies to enterprises to stay ahead of their markets and their competitors. If we go to the next slide, thanks, Alison. So in my presentation today, I'll try and give a snapshot of the commercial building automation market, and including the connectivity technologies landscape and some forecast from our market tracker report on commercial building automation. So this report, this particular slide that you're seeing here, the chart on the left represents the commercial building automation revenues that we have segmented by hardware, software, and services. Based on our research, our estimates say that market revenues for building automation, commercial building automation, are expected to contract over the next 2 years, and we don't expect it to return to the pre-COVID levels during the past year. But let's get into the details of some of our research findings. So the impact of the COVID-19 pandemic on the CBA market has been most prominent in the hardware sales, and we estimate that between 2020 and 2021, the revenues from hardware will contract year on year by about 22% and 22% and 6% respectively, before the hardware revenue starts to again grow in 2022. While the overall market also has an impact on the software and services segment that will also see short-term contraction, we expect the software market growth will see a quicker recovery, mostly from second half of 2021. One of the drivers for the software market growth has been the demand and acceleration in the adoption of new and emerging applications within the commercial building automation market. And we'll look at each of these segments. We get into a little bit more in terms of the details of each of these segments in the next few slides. Next slide, please. Thank you. So when we look at the field equipment device shipment by building vertical, it's clear that the office and retail or mercantile buildings are the two biggest building segments, accounting for almost 47% of the field equipment device shipments in 2019. While the impact has been is clear across all of the segments due to the COVID-19 pandemic and due to the regional governments across the world place lockdown and social distancing rules to contain the pandemic. They have led to most of these buildings either being completely closed or operating on very low occupancy. This have also resulted in delays, deferment, or even cancellation in some cases of certain project implementations. However, the growth in device shipments starting from, like, say, the second half of 2020 are also being driven by, say, some of these two big building segments, the office and retail, as they start implementing new vertical solutions to encourage occupants to return to these buildings, especially with new safety and security measures in place using digital tools. So in the next slide, we'll look at how some of the more occupant-centric vertical building applications are driving the demand. So next slide, please. Sorry, if you can just go back to the previous slide. Sorry, if you could, sorry, Can we go 2 slides ahead? I think the formats have been moved a little bit. Yeah, here. So we're looking here at the different application segments. So in 2019, when we looked at the vertical applications, they were primarily dominated by more of the traditional building automation systems. So HVAC, lighting, access control, fire and life safety systems used in building operations accounted for almost 93% of all the building automation system revenues. However, new vertical applications are starting to see growth at a much faster pace, especially with the pandemic. These trends, what we saw, like say in 2019, were initially starting to see some adoption in 2019, but these are actually like say, being adopted at a much larger scale in 2020. So occupant-centric applications such as space management, environmental monitoring, and cleanliness and hygiene management are starting to see a much wider adoption across building segments. They're also, like say, some of these emerging applications, what we expect in 2026 will account for almost 30% of the building automation system revenues by the in the near future. It is also important to note that much of these applications or the new applications will be enabled by sensor devices using wireless connectivity technologies, primarily due to its simplicity, ease, and speed of implementation, low cost, and also, like say, there's an increasing sense of confidence and in terms of network security with a lot of the standard-based solutions coming out in the market. So, Alison, if you could just maybe go back 1 slide, please. Thank you. So, what are the wireless connectivity? Just to understand the wireless connectivity landscape, I'll just quickly go through this particular slide. So, when you look at the connectivity landscape in building automation system or field equipment devices, wired connectivity today, without doubt, has a lion's share of the market. At least in 2019, it accounted for almost 91% of the field equipment devices shipped used wired connectivity. But this is starting to change. What we are seeing, at least in 2018, 2019, that sort of incremental growth is starting to see a much faster growth in 2020 and 2021, with FEDs using wireless connectivity are expected to grow at almost 50% CAGR in the next 6 years. So today, while we have wireless connectivity technologies such as N-Ocean, KNX, Wireless Heart, other OEM-based proprietary wireless connectivity technologies account for almost about 40% of the market share when it comes to wireless connectivity. What we are starting to see is they are starting to lose ground to more broader standard-based technologies, especially technologies such as Bluetooth, Wi-Fi, and also IEEE 802.15.4 based protocols such as Zigbee and Thread. What we estimate is by 2026, Bluetooth, Wi-Fi, and 802.15.4 based protocols will account for almost 60% of the wireless FEDs field equipment devices shipped in 2026. Now, just moving on to the next slide. Another next slide again. So in summary, I just want to quickly summarize some of the key points we mentioned in previous slides. As commercial buildings adopt or adapt to the new normal, wireless connectivity technologies are clearly going to play a critical role in both not only complementing existing building automation systems by enabling new vertical applications, but also turning existing building stock into smart premises using retrofit smart building solutions. These building solutions will not only help feed real-time data of the building space utilization, air quality, and service availability. They will also help in, like say, applications such as asset management and improving the energy usage, energy efficiency in the buildings as well. Also, while initial adoption of these technologies are currently focused on large buildings, and they've always been so even in the past, there is going to be a renewed focus, especially from some of the solution vendors, to target some of the small and medium-sized buildings as well that still remain largely underserved. it is also important to note with the growing adoption of new vertical applications that we mentioned earlier, there is also going to be an increasing complexity that comes from a fragmented technology landscape, especially as OEMs, as we see, like say, OEMs' proprietary solutions compete with more standard-based networking technologies. There is going to be an increasing requirement for a common standardized framework that allows not only for ease of implementation, but also seamless interoperability and integration, while still ensuring that security and data privacy remain fundamental to the smart building system. So with that, I conclude my part of the my presentation, and I'll hand it over to the next speaker. Thank you.
Thank you, Adarsh. So my name is Bruno Johnson, CEO of Cascoda and Vice Chair of the Marketing and Communications Work Group of Open Connectivity Foundation. And I'm just going to give a brief introduction to the Open Connectivity Foundation. So what the Open Connectivity Foundation, OCF, provides is a core framework of technology for carrying other protocols based on simple RESTful descriptions. We have a strong certification program in place, backed by some of the largest certification labs in the world. Best-in-class security, we'll talk a bit more about that later. We allow for constrained devices to be used. These are low-cost, embedded, low-power devices. And we are also operating system independent. Next slide, please, Alison. So OCF's high-level goals and vision is to make it easier for developers to deal with the complexity of IoT communications. We have a system that is almost infinitely scalable, and we allow for interoperability across virtually any IP-based network, device to device, device to cloud, or even cloud to cloud. And we support the need for multiple vertical markets by allowing the data from various existing bus protocols to be carried at the same time over an IP-based network. And this provides a path forward for future consolidation of standards, similar to what Adarsh mentioned earlier. Okay, so on to the next slide, please, Alison. So why OCF? Well, OCF is just about the largest industry-led effort to provide secure interoperability for an IoT ecosystem. OCF has liaison agreements with many of the other IoT standards, and it is based on an open specification for secure interoperable IoT. And it's also conformant to the latest standards, and we've done an awful lot of work regarding this. We'll look at that a little bit later. Next slide, please, Alison. So all of OCF's information, the standard, and the open source stack are publicly available, and they're even able to be used at no cost using an Apache 2 license. Decisions within OCF are not made by one organization or a cohort, it's made by consensus. And what we've done is brought this core framework to the market and established it so that it can be your framework for carrying IP-based bus protocol information over any combination of IP-based protocol. Next slide, please. So let's look at a bit of history of protocols inside buildings, and for that I'll hand over to Niels.
Thank you very much, Bruno. Yes, my name is Niels Gunnar Fritz. I'm working as CEO of MBS, and I'm additionally Vice Chair of Marketing for the BACnet Interest Group Europe, where I'm also a board member. Yeah, we already heard some portions concerning the OCF and the future of connected buildings with the title of this presentation. But in order to evaluate the future for a connected building, I think it's necessary to also see where do we come from and what is really building automation. How should we distinguish between a building and home automation? So in the first step, I want to draw your attention to what is really building automation. Building automation is the first step, a centralized control of all the elements that are installed in a building. For example, the HVAC systems, heating, ventilation, air conditioning, but also all the other devices that are already installed inside the buildings. Of course, you all know lighting, you know access control, security systems, and other related systems that are controlled by typically controlled by a building management system or a building automation system. And the objectives of the building automation are improved occupant comfort in the first step, but of course the owner of the building has a completely different interest. He has the interest to earn money by operating his building. So he wants to have an efficient operating of his building systems. He wants to reduce his energy consumption in the building, and therefore he wants to reduce his operating costs. At the same time, he also wants to have increased security. And for some sites, for example, for nuclear power plants, you also need historic performance documentation that may be required by the authorities. And of course, you want to have remote access, remote control, remote operation. And you also want to improve the life cycle of your equipment or related utilities. So you have a whole bunch of demands coming from the owner or tenant of a building. And building automation is an example of a distributed control system. For example, there are many companies out there owning hundreds or even thousands of buildings. And of course, you don't want to have an own building management system installed in each of these buildings. You want to have a centralized control, and therefore it's a distributed control system. And the computer networking of electronic devices has been designed in order to monitor and control all the systems over all of your buildings that belong to your company. So please come to the next slide. Conclusion in the first step, building automation for the smart home. In your smart home, you may already have some kind of automation. For example, you may have a mobile phone controlled heating system or mobile phone controlled lighting system or anything like this. But in the first step, all these devices that you may have installed in your privately owned home have one purpose. They serve the purpose to make your life more comfortable. In the smart building, in contrast to this, you will have to deal more and more with financial things. You want to reduce the cost of your building. That may also be part of your focus when you install devices into your privately owned home. But in commercially operated buildings, this is really your focus. And in this webinar, we will almost exclusively deal with the building automation, not with the smart home automation that is more or less related all to IoT devices. And these IoT devices tend to be bought and thrown away in case they are no longer operating. This is completely different for building automation. There you tend to buy a device and you want it to be operational for at least 10 years or even longer. So we in MBS have to deal, for example, with devices that have been set up on site 25 years ago. We just had such an experience. Next slide, please. This is one of the old-fashioned devices. On the example of Kieback&Peter, it's a company located in Berlin, in Germany. These devices have been manufactured, I think, between 1995 and 2005, in this area somewhere. These devices are operated by using a serial communication line, RS-232, In case you want to access and control them remotely, you need to use this serial AS232 point-to-point connectivity using 19,200 baud communication speed. And if you look at the protocol structure, it allows roughly estimated 19 data telegrams per second. So the communication speed is really low. But nowadays, you have the demand to transform this device somehow to the IoT-driven world. Next slide, please. There's a second example. It has been manufactured by JCI, and the bus protocol is called N2 Metasys. It's already a step forward. It has a serial AS485 connection, so you can attach multiple devices to the serial line, but it's still slow. And next slide, please. Even slower is the well-known MBus system. It is a metering bus. It is really, really slow, but it has one huge advantage. So you can stretch your wiring up to 1,000 meters or even further in case you are using slow communication speed. And slow communication speed for an MBus device means something like 300 bit per second. So we're not talking about kilobit or something like that in these systems. And all these systems nowadays need to be transferred to the modern IoT-driven world. Next slide, please. Oops, yeah, protocols inside buildings at present. On the next slide, we see a star, and this star is surrounded by various bus protocols. All these bus protocols are currently installed in buildings. We place the BACnet at the very top of the star arms because nowadays, according to the British BSRIA, BACnet traffic causes roughly estimated 64% of all of the building automation traffic. So it's the biggest and the widest spread building automation bus protocols. But all the other bus protocols are also still on sites, and these are, of course, not the only bus protocols that you can find. Instead, we in MBS have implemented, roughly estimated, 120 different bus protocols that currently exist in the buildings. And I am really sure that we have a lot more bus protocols still in the buildings. And now it's a really challenge to transfer all these bus protocols to the modern world. And how this could be done and how the toolkits might look like that you could use to transfer all these to the modern world will be again presented by Bruno.
Okay, thank you, Niels. Very interesting. So let's take a look at the protocols that can be used in the future. So next slide, please, Alison. So there are two important protocols that we think can be of tremendous advantage for the future of building automation systems. The first one is called Thread. Thread is managed by the Thread group, threadgroup.org, and it is a low-power wireless mesh network protocol. It's been designed to work with the universally supported Internet protocol and is built on strong open standards. It enables for communication between devices using a mesh network, and it can reliably connect hundreds or thousands of devices within one network. And it can also communicate to a wider Internet protocol-based network using one or many routers. Thread has no single point of failure, and the Thread network can self-heal. That means the network can be dynamic. The devices can move around in space over time. And Thread's based on the widely supported wireless standard IEEE 802.15.4. It supports strong network-wide encryption and a strong method for devices to enter onto the network. And the Thread group has liaison agreement with the KNX group. Okay, next slide, please. And OCF. Now, OCF is an application layer standard. It guarantees interoperability across any internet protocol-based network, including Thread. It describes secure onboarding of devices, and then once the device is onboarded, of course, resource discovery and high security. Now, what I mean by high security is end-to-end security. So unlike a network-based protocol, where all devices may be sharing a common network key, we may need security within that network for multiple stakeholders who could be using the network. So this means that the device will encrypt the data as the data leaves the device, and then it can only be decrypted by the specific device that has the corresponding keys. Now, OCF allows for device-to-device, device-to-cloud, and cloud-to-cloud connectivity. Its specifications are based on very simple descriptions using a RESTful model and CoAP, which is this Constrained Application Protocol, very standard technology used already on the internet. The specification has been transferred to a ISO IEC standard. There's a strong certification program in place, more than 500 member companies, and it also incorporates the FAIR and UPnP structures for those who have knowledge and interest in that. It is available as open source freeware and has data models for various verticals. Next slide, please. Now, Thread and OCF actually work incredibly well together. There is a liaison between the two groups, and there are already people working on commercial applications for what's called OCF-over-Thread. There are chips available that implement this from Cascoda, and this is really quite powerful because the whole system is based on strong international standards which focus on security. Next slide, please. So let's look at the issues for connected building. Next slide. Niels mentioned a couple earlier, but if we just take the specific problem of carbon emissions, the EU has stated that 40% of the EU's energy is devoted to buildings and 36% of CO2 emissions. Now, research done in London regarding the energy consumption of buildings during the coronavirus lockdown was that in April, when many buildings in central London were completely empty, the average energy consumption was still 84% of their normal energy consumption for that time of the year. Absolutely astonishing. And this shows a lack of asset management capabilities. Next slide, please. Why? Well, if we look at existing buildings, there are many different automation systems technologies used, as Niels mentioned earlier. That's access control, security, energy, control of elevators, water, lighting, heating, ventilation, air conditioning. These systems have developed over time autonomously and have not been designed to work together. Next slide. So we can describe building automation systems as operating in domain silos, and this is really a problem. Next slide. If we want to start to use information across these different domains, there is essentially a barrier to do this. On the left-hand side, we have three different domains. Let's just say one of them is heating, ventilation, air conditioning, the other one is lighting, and the top one is security. Well, at the moment, we need some kind of gateway to connect to the IT infrastructure within the building. It's shown gateways and some sort of computer sitting on the IT system, but the security system often is not even connected to the IT system in any sensible way. So we can't use information regarding occupancy sensing, PIR sensors and so on to better control the delivery of our heating, ventilation, air conditioning or lighting to reduce energy consumption. Next slide. Now, OCF has worked very hard to develop a framework that can overcome these problems. And it is a framework that supports existing data models. So it's really what we do is we provide the infrastructure that enables secure internet protocol communication of all the various different verticals. This is backed by an open source implementation compliant to the standard, ISO, IEC standard, with a strong certification program in place. And it is compliant to the well-known security standards that have been published already. Next slide. So what does it contain? It contains, on the one side, device discovery. Essentially, this means discovery of OCF devices on the network, and then resource discovery. This means that the devices are able to communicate what resources they have such that the controlling device knows what to do with it. And of course, strong security. Now, security is based on the datagram transport layer security, otherwise known as DTLS. And this is extremely important for secure Internet of Things based communication when we're going either device to device or even across public internet to the cloud. Next slide, please. The technology is built on a basket of strong international standards from the Internet Engineering Task Force, IETF. And IETF publishes RFCs, these are specification documents. So really you can think of OCF as a standard that binds together these strong international based protocols and standards together into one package that you can use. The communication can be based on UDP, TCP, CoAP, which is the correct constrained application protocol, and we have very simple descriptions using a language known as JSON. Next slide. But OCF is more than connectivity. It actually specifies the secure device lifecycle. And this is extremely important for building automation. We really consider the confidentiality of information, the integrity of the information, and the availability of the device and the information. Next slide, please. So what does this look like? Really, this means when a new device is connected to the network, we have methods to make sure that this is really the device we want to connect to the network. To discover device ownership status and establish the device owner. Secure provisioning. This means establishing a trusted relationship between devices on the network. And then ongoing management of normal operation and the roles of devices within the network over time. And then device reset and device disposal. Next slide. Now, in order to be sure that OCF really conforms to the latest standards, we have conducted a thorough overview of the existing IoT baseline standards. There are two published in the United States, one from NIST and one from the Consumer Technology Association, CTA. There's the UK Code of Practice for Consumer IoT Security, and there are two published in the European Union, the ENISA and the ETSI standard. Next slide. So if we look at all these standards and we map out how many requirements each one has, we can plot this graph. So you can see that the ETSI standard and the ANISA standard have the largest number of requirements. Next slide. So what we've done is we've taken each of these standards and we've compared every requirement to every paragraph of the OCF specification. And this is all published online. The link is given, but it can also be found through the technology page and then the security subpage. This is a tremendous amount of work, and we've done this because it's incredibly important for conformance of our devices going forward. And also, we have a dedicated security work group led by some of the strongest companies in this field. Next slide. So when we look at how OCF is mapped across these various baselines, we have measured whether the requirement is fulfilled, whether the requirement is not applicable, or whether the requirement has not been met. And as you can see, OCF really conforms to a great way to these standards, fully to the CTA and the UK standards, and we're very close on all the others. Next slide. So the next part of this is really the interaction with data models. With the OCF Core Framework, you can use your own data models. And by data models, these can be the descriptions described in the bus protocols that Niels mentioned earlier. We can reuse the OCF's open API specification. And this is an infrastructure that makes it very easy to do this mapping job. This is not a difficult job that can be done by a relatively young software engineer. Next slide, please. The specifications that OCF has created are all described as ISO IEC standards. The link is given there. And also publicly available on the openconnectivity.org website. Next slide. So how does this work? Well, you can really take your data models and apply them to the OCF framework using RESTful descriptions. And then you get the security resources mentioned earlier automatically built in within the OCF framework. And that is integral to the core architecture. As mentioned before, we have a strong certification program in place. So once you have your implementation, you can send it to certification through some of the largest test labs in the world. Code is open source and the specification is open and published as ISO IEC. Next slide. The open source implementation of OCF is called loTivity. This is a sponsored project by the Open Connectivity Foundation, and it is continuously updated and maintained. Next slide. And loTivity is truly open source. It is licensed under an Apache 2 license. It runs on various platforms. They are listed there. But in addition, Cascoda has applied it to an embedded platform based on FreeRTOS. And as mentioned earlier, it can run over any combination of link layer protocols, Ethernet, Wi-Fi, Thread, and others. And you can define your own application and data models on top. Next slide. So to start working with OCF, we have some great resources in place. First of all, we have a getting started guide. The link is given there. And this allows you to start to understand how the models are used and generated. We have resources that help you with code generation. And we have what's called CTT, the Conformance Test Tool. So once you have your application up and running, you can test it against the Conformance Test Tool. And this is the same piece of software that's used by the certification labs to check for conformance. Next slide. As well as that, we have a couple of clients available. We have what's called OTGC, which is an onboarding tool, a generic client. It's available for Android and Linux platforms. And this can be taken and used as a way of onboarding new devices onto an OCF network. It could be used by an operational manager, for example. And this code can be taken by a particular organization, skinned up, and made to look like their own product. And as a development tool, we have a Device Spy. This is a very useful tool for developers to use for test and debug. Next slide. Okay, well, given all that, let's look at a technical vision. Really, how can we use this in a practical way? Well, considering any particular building or installation, you can make your choice of the combination of link layer technologies that best fits your particular application. So Thread for low power, Ethernet for large bandwidth, robust communications, Wi-Fi, which is fairly ubiquitous, power over Ethernet, and even NB, IoT, and LTE-M. All of these work over the Internet Protocol, IPv6, and you can choose the transport, whether that is TCP or UDP. And then with the application framework, you can apply data models for your particular protocol on top. You have the power of using OCF's existing dashboard and control systems, and a little bit out of scope of this presentation, but OCF has also specified a universal cloud interface. It's a generic form of cloud interface such that you can easily move from one cloud to another, also facilitate cloud-to-cloud communication. Now, BACnet is specified up here. It could be any one of the other bus protocols mentioned by Niels earlier. Let's go to the next slide, please. Here we have an example of OCF-over-Thread that expands an existing BACnet system with secure IP-based wireless connectivity. So this is a MBS BACnet gateway. We've integrated the Thread border router, which is the router between the Thread network and the IP network, and the open connectivity stack. So BACnet, what this does is it represents OCF devices as BACnet devices and OCF resources as BACnet objects. And that means that through a Thread low-power wireless network, we can connect to what's called sleepy end devices, SED. And these are devices that in sleep mode consume only about 1 microamp and therefore can operate for many, many years from an ordinary lithium battery. The devices will then seamlessly wake up and communicate, perhaps providing humidity, temperature, air quality, volatile organic compound, or perhaps implement an actuator function. So Niels, would you like to say any more about this?
Yes, well, thank you very much. Yeah, this is one of our universal gateways, and as mentioned before, we already implemented, roughly estimated, 120 different bus protocols on these gateways. So for the trade show Light and Building that should have taken place in spring this year, we implemented, with the great support coming from Cascoda, the functionality OCF and Thread into our gateways. And we did so by implementing a gateway or router between OCF and BACnet. But of course, it's also possible to use this already existing hardware platform to integrate many, many other bus protocols, to be precise, all of the other bus protocols that we already have, by just adding a few pieces more of software. And that makes it really interesting, and this is why we really think this could be the future of building automation, because by using OCF and Thread on base of our gateways, we have the possibility to integrate all the old-fashioned devices that are still on site into new IoT-driven systems and attach them to the cloud or wheresoever the data should go to. Thank you, Bruno.
Thank you, Niels. And yeah, because of course this is an IP-based system, information from the multiple different bus protocols can be carried simultaneously across this IP infrastructure. We're not tied with one bus protocol or another bus protocol. IP supports everything at the same time. Okay, well, that's it for my section. Next slide, please. And we planned a short discussion between ourselves on OCF and ABI Research. So I think I'd like to hand over to Adarsh.
Thanks, Bruno. Firstly, thanks for all those insights on OCF and the building automation market. It's been quite interesting to see what you guys are doing at OCF. Just looking at the building automation market, there is clearly an increasing adoption of wireless connectivity technologies. What do you make of this? Is it more market pull, or is it a technology push, or is it a combination of the both? Niels, do you want to go first?
Yeah, thank you very much. Yeah, to be precise, we already got market pull requests as well as technology push requests. So, but yeah, we're really lucky because these pull and push requests went hand in hand. For example, when we met the guys coming from Cascoda for the first time, they are of course doing a technology push, but sometime before we already had a technology pull coming from a huge investor who owns hundreds of buildings, and he asked for possibilities to integrate his old-fashioned building automation to the newer modern IoT-driven world. And therefore, we have really hand-in-hand working technology push and market pull in this situation. So the push coming from Cascoda was really at the right time. And yeah, by the way, they're really doing a great job there.
Okay. Bruno, do you have anything else to add?
Well, a big thank you to Niels. Working with MBS has been a pleasure, despite the difficulties of COVID. But yeah, I would say really OCF has been extremely forward-thinking in splitting out its data models to create the core framework. So this was planned really quite early in 2019, and it implemented very efficiently. So by the early part of this year, everything was really in place. So yeah, and of course we've done this within OCF because we do see a market pull for IP-based connectivity in the building automation market for not just device to device, but device to cloud connectivity.
Okay, and so Bruno, when you're actually looking at the different network architectures, right? When you say device to device, device to cloud, even maybe a cloud to cloud architecture, how important or what is the need for, like, say, when you look at the existing market, how important is this migration from bus protocols to more IP-based protocols? Well, what is OCF doing to make that simpler?
Yeah, so what we've started to do, well, first of all, it's the implementation that we've made using a very simple framework, RESTful descriptions, and also the framework that allows for existing data models to be mapped. And this is quite powerful because it allows data models from one application or bus protocol to communicate with another bus protocol. And really this makes the job an awful lot easier for this migration. Everything is essentially done. Interoperability is guaranteed and the security framework is already in place. But I think maybe Niels can expand on that more.
Yes, of course. At first I have to state that it was really remarkable how easy it was to integrate this OCF framework into our gateways. We already know over 100 other bus protocols, and some of them took years to implement them completely. So we know that it can really be hard to implement new bus protocols or new interfaces. With the OCF framework, it took only a few weeks to integrate the whole functionality and therefore also integrate the thread functionality together with OCF into our gateways. And by doing so, you have the possibility to very, very easily migrate the old-fashioned devices to the newer world. We got the framework delivered from Cascoda, and the common framework architecture to carry the data models easily can be set up, and as soon as you have the data models, the migration can be done within a few weeks, really. And that makes the development process a lot easier, and it gives us the possibility to bring new devices to the market. And I assume that our experience can be easily transferred to other manufacturers.
That's pretty interesting. Now, when we are actually talking about these different, say, vertical applications within the building, we talked about interoperability. How important or valuable is this interoperability, both in terms of between different vertical applications, especially when you have legacy systems and then you have new sensor devices that are either complementing these legacy systems or creating new independent building automation systems like space management or environmental monitoring. Can you maybe talk a little bit about what the advantages are, say, using OCF, for example? Bruno, do you want to go first?
Yeah, I think really the advantage is multiple. As I mentioned earlier, an IP-based network can carry multiple systems data at the same time. So when a routing function happens anywhere within an IP network, it doesn't necessarily need to know whether this is BACnet information or whether this is KNX information or any other protocol. Routers will simply route the information to the right place. So we can have multiple protocols all going on at the same time, routing the information to the right place, just as we do right now with our phones using HTTP for our web browsing, SMTP for our email, and so on. And this has another advantage. It really allows for off-site control. As Niels mentioned earlier, a lot of organizations manage dozens or hundreds of buildings or more, and they really need off-site control. And this means that the power of external computing resources can be used, whether that's from a data center owned by the particular organization or from cloud resources owned by a third party. And we can even then start to use the power of AI systems. So we've started to get to a place where we can put in place policies for particular areas of our building, just as we have policies for a laptop, how it behaves regarding the screen shutting down and so on when we pull the power and it operates from battery. But I'm sure Niels can expand on that.
Yes, I think that most of the owners or tenants or whoever has anything to do with the building is really interested in what bus protocol is used in his building or what physical topology is used in his building. Are you interested if your light is switched on by using KNX or DALI or BACnet or whatsoever? For me, it's important that the light is lighting in case I'm pressing the button. That's it for me. And I assume many other people think the same way. And now the OCF framework gives us the possibility to be really independent from the underlying bus protocols. And therefore, we will be interoperable by using OCF between various domains in building automation, no matter where you're looking at. And I think, as mentioned, this is the future of building automation because it makes life easier in case nobody needs to know what bus protocol is used. You have the onboarding procedure, you simply add new devices, you have security, and have interoperable functionality between the various domains in the building automation. So that's really an interesting step forward.
Okay, so Niels, you brought out some interesting things. Now, when you're looking at a building owner, as much as, like, say, enabling some of these automation functions, they're also liable or worried or constantly concerned about the security, be it, like, say, the data security or even data privacy of the data coming out of these buildings. Now, especially when you're seeing both in terms of implementing some of the new vertical applications, use of wireless connectivity, how do you see this market pan out? How does OCF address some of these fears of building owners who are implementing these solutions for the first time, or even adding new wireless connectivity technologies or devices to their existing BMS systems?
Yeah, I will start in this situation. Coming from the owners of the buildings, or based on the information that we got from the owners of the building, security is nowadays really a base requirement for all building automation systems. And this is not only the requirement for the transport from site to cloud or between the various devices that have been installed in the buildings, but also for onboarding. And all this has been integrated into the OCF framework. And additional security is a life cycle issue. So you really need the security starting from the manufacturing over the provisioning, in-life usage, no matter between clouds or wheresoever, and finally the disclosure. And all the requirements concerning this life cycle are fulfilled, and you always have a secured and encrypted communication, and therefore you have really a future-proof investment in case you are investing in these new devices containing OCF technology. But Bruno, I assume you have additional information concerning this point.
Yeah, really a building already will tend to have IT infrastructure. So we have people who work in buildings that understand internet protocol based connectivity. And so we're in a situation really where the IT infrastructure, including the infrastructure used to carry the OCF Core Framework, can be installed and managed by those guys. And then we have the OT infrastructure, the operational technology guys, who are really responsible for the next part. And that's really relates to the application layer, or let's say the security of a particular device to connect to a cloud or to connect to another device within the network. So just to be clear, what OCF provides is more than the network-wide security that is common with basic Wi-Fi and so on. You may have the same Wi-Fi key in your house. What's required here is what's called end-to-end security, and OCF has all the systems in place to allow for that.
Okay. Again, some really fascinating insights there from both you and Niels. Thanks again for sharing all of this. I think those were the questions I had for this discussion. Handing it over back to Alison.
And that concludes our webinar for today. Thank you everyone for joining us. A reminder that a recording of this webinar will be available following the event. Thank you.
Thank you very much.
Thank you.
Everyone.
Bye-bye.